Welcome to the fifth weekly robotics community meeting. Thanks for coming. And today we have Darko, who will tell us all about Webots. Really looking forward to this presentation. So yeah, Darko, the floor is yours.
Okay. Thank you, Matthias, for having me. So my name is Darko, and I'm a robotics software engineer at Robotics. And Robotics is a company behind Vbots open source robot simulator. And in this presentation, I'm going to give a quick overview on Vbots and its capabilities. So Vbots is fully featured robot simulator. It includes a physics engine, 3D rendering engine. You have programming interface. You can a lot of pre-built sensors and actuators that you can take from Vbots database. You have a robot builder. So you have a tool that allows you to build robots and environments. And you have a lot of high quality pre-built robot models and sensors and actuators and environments and so on. So Vbots became open source like 2 years ago. And I would say that it's gaining popularity quite quickly. So it already has like 1,300 stars on GitHub. So as a part of Vbots, you have this scene tree. And this scene tree allows you to build your environment and build your robot through UI. So you can add nodes, you can remove nodes, you can edit properties of the nodes, and you can see the results immediately. So everything you change in the scene tree, the results will be visible in the scene. So you can also import meshes from pretty much any 3D format. And since recently, you can export your robot as UDF. So you can use this UI tool to build your robot, and you can export as UDF. Vbots also offers realistic simulations. So, and that's simulations are realistic in terms of like visual appearance, and that is thanks to the PBR appearance. And PBR appearance allows you to define metalness, roughness, and other properties of the texture. So it has that realistic look. And Vbots also uses shaders extensively. It includes also accurate physics. So it's based on OD physics engine, in which you can define inertia matrix, center of mass, damping, backlash, and so on. And you have like a lot of high quality models that are pre-built that you can use out of the box. It has integrated, Vbots has integrated a programming interface. So we have like some small ID integrated in UI itself, and that you can use to quickly test your robot models. It's very good for beginners because yeah, everything is integrated, but also for professionals, because you can quickly test the mechanisms. You can quickly execute some sequence of actions to test like different part of the robots. And you can do it in C, C++, Java, MATLAB, ROS, and Python. So all popular programming languages are covered. Also, Vbots is good in performance-wise. So we didn't do any comprehensive comparison, but we found this paper from the last year. It shows the CPU usage of Vbots compared to other simulators, and you can see it's much more efficient than the other two in the graph. But what amazed me a lot is this simulation of of for RoboCup. So Vbots is official simulator for RoboCup this year. And in the video, you can see 8 robots. I think they all have like 25 joints each, and they all have like backlash in joint. And we have also accurate grass simulation. So it has, the grass has its sponginess. And we have 8 camera streams at VGA resolution. And yeah, it doesn't run in real time, but it's like 30–40% of real time, which is quite impressive, I would say. If you want to get started with Vbots, you should follow the official tutorials. Definitely, like it's the way to start it. I will show you. So you have like 8 tutorials and you need like maybe a few hours to go through them. And it shows you how to build your robot model, how to program it, how to add appearance, how to change environment, and how to use those, like some basics. Also, oops. Also, if you prepare video tutorials, there are video tutorials that we did with a guy from Google Summer of Code. But in this presentation, I'm not going to describe basics. I would like to, I picked a few features that I want to present just to spark your creativity. So great thing about Vbots is that it has a lot of examples. So if you go to File and Open Sample World, you'll find a lot of examples. You just type a few keywords and you will find what you're looking for. So there you have examples like of sensors and actuators, how to model them, how to use them. Like each robot has its own simulation, at least one. There are a lot of environments and there is like tutorials how to use Supervisor and so on. What's interesting is this how-to part. So those are some interesting simulations that are not typical just how to use the device, but more advanced. So this, for example, describes how to define asymmetric friction, how to build a robot window, how to apply artificial force on your solids, how to catch mouse events, how to create omnidirectional robot with omnidirectional wheels, how to extend the physics, so you can extend physics of Vbots, how to use OpenCV and so on. So you can go, those are very interesting simulations. Of course, you have more here. Another interesting thing is Supervisor. Supervisor allows you to, it's like a robot with superpowers. It allows you to add, remove objects, move objects, apply force, read object position and velocity, control simulation. You can like start simulation, reset it, put in the fast mode and so on. And also you can retrieve contact points, and there are many features. So you can, this is one example of using this is in reinforcement learning. So basically you can, in reinforcement learning, every time you finish the episode, you want to reset your simulation, and then you want to randomize the environment. And all of this you can do with this supervisor node. So you can follow this link down here to get more details. So in Vbots, you can create something that we call robot windows. You can see here in this video. So in this case, it allows me to control the arm of the robot, but you can also read sensor readings. You can show sensor readings, and it's very useful for quick tests. And the great thing about that is that you can easily create your own robot window using the HTML5 and JavaScript. There are like two functions just to send data to controller and one function to retrieve data from controller. I saw people using like this robot window to visualize a particle filter, stuff like that. So it can be used like as a substitute of the RVs in some cases. So also Vbots offers streaming. So you can start simulation in Vbots and then you can stream it online. And then you have like, you can open that in web browser, open simulation in web browser, and then you can like rotate it, play it, and so on. And the great example of using this feature is Robot Benchmark. So Robot Benchmark is the product of Robotics. So let's pick one simulation. Yeah, because of streaming, it seems that my computer is a little bit slow. So in this case, the rendering is done on the client side in the browser, but the physics and the controller execution is done on the server side. So if you right click on the robot and you go to edit controller, you can see like code like this. So this is basically your controller, your robot controller, and you can edit it, and then you can click a play button and your simulation get executed. And you see the robot doing its own thing, picking the object. So, but you also can record the simulation and export that as HTML model and HTML5 web page, and you can share that web page with your colleagues, with your other researchers, and so on. So you can show your presentation. One example of that HTML5 is this one. So this is now a room. Let's give a moment. Okay, here. And as you can see, you can move around, you can rotate, you can zoom. And here you have like a playback status of the simulation. But then we go, then we thought like, okay, we can export animation. Can we somehow publish it automatically? And we created a GitHub Action. So now we have a GitHub Action that allows you to create HTML5 animation out of the Vbots project. So every time you push a new commit, it will export HTML5 movie and publish it on GitHub pages. So you can imagine developing project and sharing that with your client, and your client will always be updated about your status. Or you can use in CI, for example, with the unit tests. So imagine that you have a robot that has to go to a certain location and you're checking whether the location is reached. If it is reached, then great. If no, then it's very nice that you create HTML5 animation of that failure so you can easily inspect it. And the project that uses it is like, for example, this one. This is a project that a simple project that I created. It's actually answered to Stack Overflow. User asked like, how can I follow the Red Bull in Vbots simulation? So I created this project to demonstrate it. And then you can click here. And in a moment, you will get like simulation. So, and that simulation is generated automatically in CI. So if you check your workflow file, you just include our GitHub Action over here. And you define this Vbots YAML file in which you include your dependencies and which world you want to record. And now every time we update this project, a new simulation will be published on GitHub pages. Then we recently introduced camera segmentation. It allows you to get a ground truth segmentation of the world. So you can see here in the picture, in the GIF, the cones are segmented as well as buildings. So you can imagine this using in your computer vision project to train your deep net to perform segmentation. Also, you can integrate your Vbots. You can integrate Vbots with OpenAI Gym interface, and then you can use a stable baselines algorithms from stable baselines to train your agent to perform something. You can see here, it's training to do inverted pendulum. Yeah, and it's very simple. So if you go here, you can see the code actually. So I think it's like less than maybe 50, 100 lines of code to create a controller for this simulation. So it's, I would say it's quite simple to do integration. Vbots has interface with ROS and ROS2. And at the moment we are focusing development on ROS2. So in case of ROS2, we have a translation layer, which takes your robot model that you modeled in Vbots. And based on that, it automatically creates the necessary topics and services. We also provide a lot of examples. So we have many examples of ground mobile robots. We have also a lot of examples of robotic arms. And we have one example of a drone and vehicle. It supports multi-robot systems. And we have a tool which converts URDF to Vbots proto. So a Vbots proto is equivalent to like Xacro in ROS. So I will give you a quick overview of our plans in the future. So regarding ROS2 support, we plan to introduce ROS2 control integration and URDF importer. So you saw that you can basically import, you can convert URDF to proto file, but we plan to integrate URDF support deeper into Vbots core. So you don't have to perform that extra step. We wanted to introduce better web support. You just saw that we have a lot of web things. What we are doing right now, and the pull request is nearly finished, is that Vbots has its own rendering engine that is coded in C++ and it's called run. So we're compiling that run in WebAssembly. So we have very high fidelity simulations in the web. We have the exact same simulations in the web and in the Vbots interface. We would like to allow sharing simulations in a single click. So basically you click share this presentation, you get a link, and then you can share with your colleagues and maybe other researchers. And we would like to organize competitions. So we have something, we use that GitHub Action that I previously introduced to generate competitions. So the idea is that you have like a lot of competitors and they all register their repositories and they push controllers in their repositories. And then we collect all of that in GitHub CI and we generate matches and we publish it on GitHub pages. So we have a base for it. We introduced some support for that, but we need to organize a competition to really demonstrate how it works. And we want to improve support for reinforcement learning. So in scope of OpenDR project, we are integrating Vbots with deep learning frameworks. And in scope of Optima project, we want to deploy Vbots like Vbots and reinforcement learning on high performance computers. And I would say that's it. So visit our Discord community. We have a lot of members there. And if you have any problem, we can help there. This is linked to our project. And if you have some questions or some kind of business inquiries, feel free to mail us.
Thanks, Darko. That was really interesting. So now we are about to go into questions. So I think we have 14 participants. So let's use chat and just write your question, and then I will read it aloud. And Darko or Olivier will do their best to answer them. So the first question is from Ignat. He says, I didn't exactly catch what are the distinctive features of Webots in comparison to other similar simulations. Comparisons to Gazebo are somewhat obvious, but I would also like to hear comparisons to other simulation that targets high visual fidelity, such as Isaac Sim. Have you seen Isaac Sim? I think it's from NVIDIA.
Maybe.
Okay.
Maybe. I know that NVIDIA, I think NVIDIA works with some game engine, but I don't really recall. So we didn't do any like good comparison with other simulators, so I cannot like tell you what's the advantage. I know that NVIDIA relies a lot on game engines, and game engines usually don't have very accurate physics. So on the visual side, maybe they may be better, but in case of physics engine, I would say that Vbots is more accurate. But this is like, I don't know. I have to try all of them so I can compare, and that takes a lot of time. I guess that's the reason why we are doing this presentation. So we present what we can do with our simulator, and then you see what you can get with other simulators.
Maybe I can add some precision. Can you hear me? Yeah.
Yeah, we can hear you, Oliver. Go on.
So I would say that simulation like Isaac Sims is something which is done by NVIDIA, and obviously they are very good at graphics and also physics engine, but not that much at robotics, which means that they do not provide calibrated sensor models. They do not provide a library of actuators, sensors, robotic scenario, and so on. And so I would say also regarding interfaces, like interfaces with different programming language, interfaces with ROS and so on, the ROS ecosystem, I would say that those simulators are less powerful than simulators like Webots or Gazebo, which have much more development background in robotics. And so also some people often compare Webots with like a simulator like ADAMS, which rely on finite element physics. And obviously those kind of simulator are much more accurate, but they don't run real time and they're not well integrated. They're more generic simulator and not well specialized in robotics. So they lack sensor modeling, they lack integration with robotic system and so on. So I would say Webots is more in the class of simulator, the same class as Gazebo and VREP and other simulator which rely on fairly simple physics engine, fairly simple rendering, and they produce a real-time performance.
You've mentioned sensor modeling, and I think this is quite interesting. Can you maybe expand on this? One of you guys. I think at one point, Oliver told me that you support, for example, motion blur for cameras. And to me, this sounds like a very neat feature because you still use simulator, but you can simulate something you actually see on the physical robot. And for me, that's quite interesting.
Yeah, this is the goal in Webots, to be as close as possible to real devices. And the camera is a very good example because in Webots, you can configure the camera so that it's very realistic. The first thing is that we use physically based rendering, as you could see, with different material for the appearance of the metalness and the roughness of material and so on, which provide very realistic images. We also have stencil shadows, which are very realistic, but also at the camera level, we have spherical projection, which is much more realistic than the planar projection you get, for example, with Gazebo or other simulators. You can also add white noise, different kind of noise on the camera. There is this motion blur that you mentioned. There is also focus. So depending on the distance of the object and the focal length of the camera, you will get some fuzziness on the image. So all those aspects are making the sensor very accurate and very close to the real devices. And so the simulation you will get, the problem you will encounter in the simulation will be the same problem that you will encounter when you move on the real hardware. And if you can solve those problems in simulation, they will be solved when you move your control system to the real hardware. So this is the goal of Webots, to provide some very accurate library of sensor that you can configure, and that will speed up your robotics development in the sense that when you move from simulation to the real robot, you will face exactly or the very same problem. So this is something very important. Also for most of the sensors in Webots, you can provide a lookup table that will define the return value according to the measurement, and that can include noise as well. So in Webots, you have a realistic sensor in terms of noise and response of the return value of the sensors. And this is something which is very important to us. We have been calibrating a number of sensors against real counterparts. So we have been calibrating complete robots like the EPUC robot or the Darwin OP robot, but also sensors like different type of leaders. And all those aspects, including noise, optical aberration, and so on, contribute to have very, very realistic sensor models, which you will not have in ISAACSIM, for example, or in ADAMS or in other simulator. Even Gazebo is much less accurate with respect to, for example, camera modeling.
Cool, yeah, that's, yeah, I really, for me, this is one of the killer features, I think, checking out your simulator. Okay, let's jump to the next question. Does Webots have some hardware requirements for running complex simulations with high visual fidelity? Does it require GPU acceleration, and what would be a reasonable minimum requirement?
That depends a lot on simulation. Like you can run on Intel GPU, it will work fine. But if you want some kind of more complex simulation, it will require like dedicated GPU.
Let's say you've showed us the Turtlebot. So if you had this plus some camera and one single plane LiDAR, would it still be okay for Intel's graphics card, or?
I'm not sure because laser and camera are hardware accelerated. So maybe.
Okay.
I haven't tried.
Yeah.
I can try them on my laptop at some point and tell you.
I think so. I think it could run on some recent Intel graphics. I have tested on my laptop this demo. It's running obviously slower than if you have a very powerful NVIDIA and very powerful CPU, but it runs at a decent speed even on some Intel hardware graphics.
Okay.
Cool. Yeah, I think I was running a Spot. I'm not sure, but I think I was running Spot on Intel GPU, and it has a camera stream, and it was running maybe 4 or 5 times of real time. A Spot Mini robot.
Yeah, 5 times higher than real time.
Yes.
Oh, good. That's good. Okay, let's see another question from Bruno. Great work. I also have a question. Does Webots have a motion planning environment, or you guys use Move-it for that purposes?
It's Move-it.
Move-it.
We published a library, IKFast. So you can take your robot model from Vbots, and it will generate like analytical solutions that you can use for inverse kinematics. And IKFast works like under like it generates solution in a few microseconds.
And this is all. So this is a plugin, or is it part of Webots?
It's not a part of Vbots. We were developing some external project, like internal project, and we figure out it would be nice to adapt IKFast so we can use it with Python. And yeah, Vbots allows you to export URDF. You take that URDF, you pass to the IKFast, and it generates solutions. It generates actually Python library. So what we developed there is a Docker image that has all tools necessary to generate IKFast library and a Python interface for it. And of course, you can use Move-it with ROS1 and ROS2. We have examples of it.
And does it? Do you require any plumbing to get it running with Move-it, or is it pretty much out of the box?
In ROS1, we have ROS control integrated. So it goes through the ROS control. And in case of ROS2, we have a joint state publisher and trajectory follower. Those like 2 modules necessary for Move-it. We coded those in Python, and that's like, but you just say, I want to use those, and it will work.
Nice. Then Dennis says, good job, Darko. Thanks for the talk. Drake is saying, thanks, Darko. Do you have any recommendations for learning how to use ROS2 for controllers? I think the Cyberbotics sorry, Cyberbotics docs only have ROS for now.
ROS 2 tutorials, right?
Yeah, so I think using ROS 2 for controllers with Webots, I assume.
Okay, so maybe like with ROS control, like controllers from the ROS control, right? I'm not sure if I understand the question.
Yeah, maybe Drake can clarify in the comment, and then I will jump to the next question. Another question from Bruno. Is there any projects for grad students who would like to study or work with Webots, like a summer project, for instance?
I think that's a question for Oliver.
Okay, yeah, we are accepting master students on a regular basis, but not graduate students. And we're located in Lausanne, Switzerland. So I don't know where you, Bruno, are located if you're interested. We usually don't work remotely with students. It's a little bit difficult, but yeah, we are open. So I don't know how you, it could be also that at your local university, you want to work on a Webots project. And so you have a professor for that will be responsible for your project. And then we can discuss with your professor to see if there is interest that we somehow support this kind of project. So let's get in touch with us to discuss this opportunity, but we are open.
And I think at one point you did Google Summer of Code, right? Are you still doing that, or
Google Summer of Docs?
Last year we did Google Season of Doc, and we had one author who wrote some documentation about Webots, and we applied again for Google Season of Doc this year. We will get the results very soon. I think it should be within a couple of weeks. And if it gets accepted by Google, we will inform the community about this possibility so that you will get paid by Google to write some documentation about Webots. But we just apply and it's not yet approved by Google. So we have to wait until we get the approval.
Okay, so I think your Discord is the best place to stay up to date on that, right?
Yes.
Yes.
Cool. Okay, we have some more questions. Francois is saying, hi, do you have any pointers to work involving the development of manipulator arms calibration algorithms, kinematic and or dynamic using Webots? The point mentioned by Oliver make it seem like it would be good to try it.
So that's about calibration of the robotic arms.
Yeah, with your simulator.
I mean, you can, for each joint, you can specify like the torque of the motor, the maximum velocity, the maximum position, minimum position, stuff like that. So I don't know any specific package for that. Also, since recently, you can also specify backlash. I mean, you have like, I guess you have all properties that you need. You can configure everything you want, but I don't know any algorithm for calibration of the robotic arms. I'm not.
Okay, so that's probably something to look into in the future, let's say. Then Bruno wrote, thank you so much for the answer. I've used IKFast with MoveIt and ROS1 in the past. You can even disable some internal collisions for speeding up the calculation. It's a great library. Thank you for your response. Okay. And then Bruno also thanks you very much for the information you gave him regarding the opportunities for students. And then Drake clarified his question. He says, I'm fairly new to robotics work and my team is using ROS2, but I'm not sure how to control a robot with ROS2 in Webots. Do you have recommendations for how to learn that? Maybe learning from the examples in Webots ROS2?
Yeah, but I think Darko already gave pointer in his presentation about a series of video tutorial using ROS. So maybe you can get back to that point. Actually, the guy who did the Google Season of Doc last year covered the topic of ROS2 integration with Webots. And he produced a very nice series of video tutorial. You can see the link here. It really starts from scratch, installing Webots, installing ROS2, and then writing your first ROS2 controller with Webots. And then it's going deeper and deeper using advanced techniques with ROS2. I don't recall exactly the detail, but he may address different kind of navigation, inverse kinematics, trajectory generation, things like that.
Yeah, I think he was also using mapping. Yep. And the final project is like something with computer vision, like following QR tags, something like that. Yeah, you can follow this link for the video tutorials.
Mm-hmm. This presentation will be available under the video when we post it on the Weekly Robotics channel. So you'll be able to click it if you don't want to type this URL by hand. And then Francois said about your answer about the calibration. He says, thanks, we are working on that subject for a new kind of robot. If we use Webots for it and have good results, we will let you know.
Great. I mean,
yeah, so stay tuned.
You can also like reach us on Discord, where we can discuss details. And if you need any help, we will be there.
Cool. Now, question from Alan. How much can we do with animations? We are working with a drone robot system and we would love to implement more testing with sims. It would be great to get the visual feedback animation and superimposed flight plans, altitude, camera views, and etc.
So there is you can generate animation for drone, that's no problem there. But at the moment we don't export images. So if you have camera stream, that's something that we don't export at the moment.
Mm-hmm. I think this might be slightly related to your CI setup with GitHub that you've mentioned. So the output of this, is this a simulation or just a video?
It is animation. So that means that you can, you replay the simulation. You cannot affect the simulation, you can replay it. And you can change a viewpoint. So compared to video, you can change the viewpoint.
Yeah. Okay. I actually had a question about that. Do you also can define some passing or fail status in this GitHub Actions?
What do you mean?
So for example, let's say you want some continuous testing for your robot, and then you create this scenario where a robot needs to go and pick an object. So travel to the object, pick it up, and then let's say place it in another place that you designed. And then you iterate it, you make a new commit, you push it, and then your simulation runs automatically, I assume, with the GitHub Actions.
Yes.
And then would it be possible to specify that if the robot fails to drop the ball in the specified place or in any other at any other point of the simulation, you could say that, okay, this action actually failed and you've broken the code, basically.
Yes, it's possible. So that's something that we are doing for Vbots itself. So we have a lot of tests of API and physics and rendering and so on. And we are running Vbots inside of CI. And then we are testing whether the robot reaches the destination or whatever is necessary for the test. So, and for that, you will need to use like GitHub Action and this supervisor node. This supervisor node allows you to check the position of the robot or your object. And you just check if it's like in certain region, then you say like test.
Yeah, okay. Yeah, that's quite exciting. Yeah, let me say, yeah, I have to say that Robot Benchmark, I followed your progress for quite some time, but I didn't see it before. So it's good we are doing these presentations. I can catch up. And just to be clear, so in this robot benchmark, you can simulate, you get these simulations that work out of the box. You write your own control code and you can execute it, right? Did I catch the gist? Okay. Yeah, that sounds, I actually feature it in Weekly Robotics because I think this is great learning tool for students. It should be amazing.
Yes, actually we noticed that a lot of students use it. I think some professors use it. So every time you finish the simulation, you get a score and then you get ranked compared to other participants. So I guess some professors are using that for grading the score on the platform.
I think yeah, interesting way. Okay, I know I don't have any more questions, and there are no more questions in the chat unless anyone has anything else to add. We have one message from Tolga. Thanks for the presentation. It was very informative. And then from Alan, thank you so much for the presentation and the answers. So if there are no more questions, we can stop this official part. And then usually after these meetings, we do like a free chat where we can touch on different topics, or everyone in the meeting will actually get the chance to chat and ask your own questions if you have any further ones. Okay, I assume no questions then. So thanks a lot for joining. Thanks a lot for the presentation and the answers. It was great to have you, Darko and Olivier. And I will be looking forward to see how your project grows and to spend the weekend with this finally.
Thank you for having us.
Thank you, Matthias, for organizing this very nice meetup.
Yeah, I hope you like it. Yeah.